am taking a small class about different type of gaseous law. So I think there is no introduction about what you mean by gases. Such that gas is a fundamental matter of state like liquid and solid. So it has some special characteristic like that it has no shape, no volume as compared to other states, and also it has more compressible and it show high diffusion rate compared to others. So gas has some particular difference between the other state. So just coming to the topic, why gases law? Why we are studying this gases law? So finding the relation by studying this gas law, we can find or we can find we can calculate a relationship, make a relationship between different parameters, measurable parameters of gases like such as temperature, pressure, and volume. From this gas law, we can find a relationship between these parameters. Hence, we can find the state of any gases at any condition. So, by this law, we can find this. So, there are four type of gases law. One is Boyle's law, Charles law, Isaac law, and Avogadro law. Then I'm discussing each by one by each. So firstly, Boyle's law. It's a simple law which says that at constant temperature, pressure of a fixed amount of gas is inversely proportional to its volume. Constant temperature, pressure is inversely proportional to its volume. So this, for example, I'm just saying the example for this law. Then when we are pressing or squeezing the balloon, it gets decreased. So what happens in that state? We are just pressing, or just that means that we are applying pressure. We are increasing pressure, and the volume is decreasing. So pressure is inversely proportional to its volume. So from this equation to avoid this proportionality, we just taking a constant. Then we are plotting the graph for this law, that we are taking pressure in the y-axis and 1 by the in x-axis. So from this equation, we can find that which is like similar, like directly proportional to 1 by x. From that mathematical form, we can find that it is like we get a plot which is a straight line and passing through the origin. So this is the graph of Boyle's law, and we should clarify that it is taking at a constant temperature. So this graph is known as isothermal graph. That is, we are taking the graph at constant temperature. So then just think of other cases when we are changing the temperature. And that case, when changing the temperature, that I am just increasing the temperature. T3 is more high temperature than T2 and T1. This is the graph of T1. So what happened here is that the curve is upshifted, which means that when temperature is increasing at a constant volume, or at that time when temperature is increasing, kinetic energy of a molecule is getting increased. So it will collide the container or the wall of where we are taking the gases. So the pressure are get increased. That's why here we can see the slope of the T3 is higher than the T2 and T1. That higher temperature, the change of pressure will be more. So that's reflected in this curve. This is the basic concept of Boyle's law. So I'm going to discuss about the charge law. like similar like Moore's law. It says that at constant pressure, when we are maintaining a constant pressure, the volume of a fixed amount of gas is directly proportional to its temperature. That this is the law. This is the principle of this law. So, at maintaining pressure, constant pressure, when we are increasing temperature, the volume also increases. So, just for taking an example as a balloon, similar I discussed. When taking a balloon, that blown balloon in the air or head in the outside the under sunlight, we are just heating that balloon. So volume get increased. When temperature is applied, the volume get increased and the balloon will become because volume is increasing when applying temperature. So this is the law discussing in this law. So this pressure at constant pressure, volume directly proportional to temperature. So similarly, we are discussing earlier proportionality stuff. So discussing about this graph, we are taking volume as in y-axis and temperature in the x-axis. We are getting similar like manner. This is the graph of the Charles law. That volume at y-axis and temperature at x-axis, and this is done at a constant pressure. So this graph is known as isobaric graph. So this is the graph, and similarly we are changing the earlier we changing temperature, where we are changing the pressure. The graph will be like this. P3 will be higher temperature and P2 will be P3 will be higher temperature than P2 and P1. So this is the basic things discussing about the Charles law. We are firstly moving to the next topic. Next law. That is law. This law states that at constant volume, pressure of a fixed amount of gas is directly proportional to its temperature. At a constant volume, pressure directly proportional to temperature. This is similar like Charles law. That in that case it was volume. In this case it was pressure. And the graph is similar like Charles law. The pressure is y-axis and temperature in the x-axis. So we get a straight graph like this. Graph like similar manner that Charles law. So this is the graph of Charles law. So this is the overall basic thing. This is the only basic thing discussing in this law. Then we are moving the next law. That is what law? Avogadro's law. So Avogadro's law. Just in this law, at a particular volume, at a given volume, when we are taking equal amount of volume, that we are taking a container of equal volume. If the temperature and pressure of that all containers are same, then the amount of the number of molecules seen in that container will be same. So at constant temperature, volume directly proportional to number. This equation. This is a simple equation stated by Avogadro. And the graph is volume directly proportional to number of molecules at a constant pressure and temperature. This is simple for last law. So we are discussing about the four law. From this we are getting a assumption, we are getting a finalization for this four law. When we are combining both law, we get that E directly proportional to 1 by the for Boy's law. Then we are adding temperature, when applying temperature, then pressure directly proportional to temperature, that's Stark's law. Then we are applying Avogadro's law. So this is the overall law, the combined law. This is the overall combined law equation for all the four laws. So this is the final equation we got from this four law. So for avoiding proportionality, we just introduce a new term R. We are just rearranging it is E equal to R T. This is the Penrose equation. This is the ideal gas equation. This is the famous equation, ideal gas equation. R is the universal gas constant. So from this, I said earlier, by studying this R law, we can find the states of a gas at each stages. So from this, we are just rearranging it. This is the constant, and we are taking the number of molecules as a constant. So this both will be a constant. So So from this we can ultimately make these equations that P1 V1 equal to P1 ultimately we can make this equation. This is the combined gas law. From this gas law we can find the different states of gas. At each stages we can find the states or parameters of this gas, variable parameters of this gas. So I'm just taken the content and now discuss a small questions related to this. So I'm just writing your questions. At this is simple questions that at 25 degrees Celsius and 760 mmHg pressure of gas occupies 60 ml. What volume? Then what will be the pressure at height where temperature is 10 degrees Celsius and volume is 64 ml. So this is simple question. From this equation we can find the answer for this. That I converted degree Celsius into Kelvin. This is nothing more than I have from this. I'm just writing, and then we want to find to the P2. I will be the final pressure. This is the thing we want to find. So by law of space, I'm just utilizing this. So from that we can get P2 equal to P1. We want to find P2. For P2, just take T2 here and go T2 here and V2 by denominator. Just rearrange that equation and we finally get P2 equal to P1, 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 and T2 will be here and T2 and P2. So this is the final. This will be the final answer. 600. This will be the final answer for this. There is no unit conversion, so I will just simply write it and got the answer in pressure in mmHg. There is no unit conversion, so I am not mentioning any unit in this question. So this is the as I earlier stated that we can find the state of any state of volume at any stages. So we are measuring the pressure, final pressure of this